Hello, this is Nicholas Sayer, and I'm going to show you the second extra credit problem now. So this problem is on computers and printing. So with this function, I took the rand function twice, and then I decided that if the absolute value of the difference between the two random values happened to be less than 20 minutes, which is the printing time. Here it's shown as 1/3 because a third of an hour is 20 minutes, and the rand function gives you a value between 0 and 1. So if the difference of these, if the collision condition is met, then I'm going to increment a collision counter. And that's the first part of the function. The second part is to decide the waiting time. And so with the collisions, I had the sum of the collision counter divided by the number of trials, just like in the first problem. For the second part of the problem about waiting time, I decided there was two different cases. There's the case where you don't have a collision and the case where you do. And if you don't have a collision, then the total time you have to wait is going to be the larger print time, or the computer that started last, plus 20-minute time to print. And so that's what this part does, is the larger the time it takes for the computer who takes longer to start printing, the wait time is going to be that number plus 20 minutes. And then it ends up being the other computer is larger, then it's that one. And if there is a collision, it's going to be a slightly different case because it's actually going to take 40 minutes longer than the first computer to print due to the queue concept, that the second computer to print in the collision gets queued, has to wait for the first one to finish, and it kind of loses whenever it started, it has to wait. So with that, same statement, which one's bigger, but this time, if this one's bigger, add the second one to the wait time plus 2/3. And I just got cumulative wait times and cumulative collision wait times. Here, these only appear in the collision case, so that we can get a mean value for that. And yeah, take the total wait time divided by the number of trials. In this case, this is the total collision wait time divided by the number of collisions. And then we can run it, and you see here, you can do it a number of times. You can see they stay pretty consistent. The probability is about 0.55 repeating. The mean wait time is about 66 minutes. And the mean waiting time in case of a collision is about 70 minutes. So it's about 10 minutes more if there's a collision than the total 1 hour time period. And that's problem 2. Thank you.